Hello friends, here we are given a question. Find the derivative of fx is equals to modulus of x at x equals to 0. So this is a modulus function we have in this question, and here we are asked to find the derivatives of modulus function of this one at x equals to 0. Now if you see that question, it seems to be easy one, isn't it? Before going to the solution of that question, I want to introduce you some definitions here, because this question is not easy as you think. So let's see. So here we have to introduce some definitions like left-hand derivatives and right-hand derivatives. So what is left-hand and right-hand derivative is? So left-hand derivatives means this is a derivatives, okay, left-hand derivatives. So if I belongs to in real numbers, then we called a function f such that I is tends to r, okay. So then these functions f is said to be left-hand derivatives. Suppose we take some point that belongs to I, okay, then this f is said to be left-hand derivatives at c if their f dash c equals to limit of f of x minus f of c divided by x minus c as x tends to c left hand, so c negative. That means what from c the x approaches from left hand side, so we denote it by c negative. That's not meant minus c, okay. So again, if the derivatives is approaches to the c from the right hand side, then it is denoted by c positive. So then we called it a right hand derivative, okay. That is like that. If I is the subset or belongs to R, then f of f will be defined as like that. And c, suppose c is a point under I, so then we called f dash c is equals to limit x tends to c positive, that is f of x minus f of c divided by x minus c. Then this is called right hand derivative, and we call the derivative exist if their left hand derivative and right hand derivative are equal to each other. So that means left hand derivative, so this left hand derivative is denoted by like L f dash, okay, and right hand derivative is denoted by R f dash c. So left hand derivatives can be written as L f dash c, that equals to right hand derivative R f dash c. Then we called the derivative of f dash c is exist. So that's the definition we have to know before solving this question, okay. So since this is a modulus function, so we can say that there exist three cases of x. So let's write it elaborately, then we can understand that is modulus of x. So this is may equals to minus x if that x is less than, okay, less than 0, okay, and x is that modulus of x equals to 0 if x is equals to 0, and x is positive if x is greater than 0. We have to study that all three cases for this differentiation, for this question. So before differentiate this modulus function, then at x equals to 0, we have to take it either that x for left hand derivatives and right hand derivatives, okay, they exist or not. So we first of all find the derivative of this x less than 0 for x less than 0 and x greater than 0. Then So let's see for each case. So if x less than 0, then the derivatives is called the left-hand derivatives. Okay, left-hand derivatives. So we denote it as L f dash c. Here c is 0 because we are asked to find the differentiation of this modulus function at x equals to 0. So that means c means here it is 0. So that limit of, according to the definitions of the left-hand derivatives, we use that is x tends to, since it is left-hand derivative, so 0 negative. So this is fx minus f of c means it is 0, and divided by x minus c means it is 0. Now since fx as at x equal x less than 0, we have minus x. So putting that value in here, then we come to know that this is equals to minus x, and this f of 0 means at x equals to 0, that is 0. The modulus functions fx equals to modulus of x. So we get here minus x by x, and that is equals to what? We get minus 1. Okay, we get the left-hand derivatives of this modulus function at x tends to 0 negative, then it is minus 1. So let's discuss for the next case, that is right-hand limit for x greater than 0. So what about it? So according to the definition, right-hand derivatives is also denoted by f dash 0. So this is limit is x tends to 0 positive, x approaches to 0 from right hand side. So that's why it is denoted 0 positive, we know that. And this is f of x minus f of c means it is 0, and divided by x minus 0. So if we see that, we know that this f of x at x less than, x greater than 0, it is f of x is equals to x. We know that. So that means we can put that value in here. So this is x, and f of 0 means it is 0, and divided by x, and that gives us a value that is 1. So we have that the left-hand derivative at 0 at x equals to 0 and right-hand derivative at x equals to 0, they are not equals to each other. So we know that from the definition, a derivative exists if their left-hand derivatives and right-hand derivative equals. From here we have seen that they are not equals to each other. So the derivative at x equals to 0, f of x, that's modulus function f of x equals to modulus of x at x equals to 0 doesn't exist. From here we have the final answer that derivative of f of x is equals to modulus of x at x equals to 0 doesn't exist. Okay, that's the final answer. So if you are asked to find the derivative of any functions, then you have to examine their left-hand derivative and right-hand derivative as well. So after that you come to know that derivative exists or not. It is the case for higher studies. Whenever you are going to a higher study of mathematics, then you will get this. So for high secondary level they are just you have to use the general form of the differentiability formulas, and you can get it, because differentiations of 0, it's kind of possible. So that's what this doesn't exist. Thanks for watching. If you are new in this channel, then please like, share and subscribe it. See you soon in next video. Until then, peace. Bye bye.